Okay, so this is extra practice review for the Unit 2 exam for Honors Math 3. So this is just some extra practice if you want to do. So what I would advise you to do is once you see the question, I don't have the directions written down, and you know the directions, is to go ahead and press pause, try it on your own, and then you can press play. You can kind of fast forward to see, do you have the right answer, watch me work it out. But you should definitely be going back and forth between pause and play. So the directions on this type of a problem would say something along the lines to solve for x and have your final answers in interval notation, perhaps even graph on a number line, but that's what this would essentially ask you to do. So our first step is we always want to isolate the absolute value. So to isolate the absolute value, I'm going to get rid of the 3 and get rid of the subtracting 2. So in order to do that, we want to make sure we're following the correct order in which we're solving. So we cannot combine the 3 minus 2. So I'm going to move the 3 to the other side. So I'm subtracting 3. And then once I do that, 3 minus 3 is 0. So then I would have negative 2, absolute value of x plus 4. And then less than 7 minus 3 is 4. Okay, so again, right, we're isolating the absolute value. So I'm going to get rid of the negative 2. I don't want to add it over because it's multiplying. So I'm going to divide both sides by negative 2. Whenever I multiply or divide by a negative number, I want to reverse the inequality. So instead of less than, it's now greater than. And then once I get to here, I need to decide, do I create 2 equations, 1 equation, or no equations? So if this was a positive number, I would create 2 equations, one for the positive version and one for the negative. If it was equal to 0, it would just be 1 equation and I would solve it. If it were equal to a negative, then I don't continue to solve, right? No equations. So because this is a negative value, I have to decide, is it a positive, what am I saying? If it's no solution or all real numbers. So what I look at, so I have absolute value of x plus 4 is greater than negative 2. So this portion right here, absolute values, generate positive numbers or 0. So then what I ask myself is, how many positive numbers, or what positive numbers out there, are greater than negative 2? So what positive values are greater than negative 2? And that would be all of them. So this would be all real numbers, or infinitely many solutions, of course. And then I could also write it negative infinity to infinity. So x can be any value, and it will always be greater than negative 2. Okay. Let's do the next one. So same directions. So again, it would say something like to solve the values of x and either graph on a number line, write your answer in interval notation, something along that lines. So the first thing I want to do is isolate the absolute value. So in order to do that, I need to get rid of the negative 3. So it is multiplying here. So then I'm going to divide both sides by negative 3. And I'm going to try really hard to always remember, whenever I do that, I want to switch the inequality because I divided by a negative number. So 6 divided by negative 3 is negative 2. And then I switch the inequality. So now whenever I have an absolute value, I need to pay attention to, do I want to keep solving, or do I have to stop and think about my solution? So if this was a positive number, I would create 2 equations and continue solving. But because it's a negative, I have to decide, is it all real numbers or no solution? So I want to take a look at this right here, and I remember that all absolute values generate positive numbers. So then I ask myself, what positive number out there is smaller than negative 2? So what positive number is smaller than negative 2? And that would be none of them. So there is no positive number smaller than negative 2. So then this would be no solution. Okay. All right, and then let's take a look at one more absolute value problem. So one more. So again, we want to isolate the absolute value. So I'm going to add 4 first. And then I want to get rid of the 2, which is multiplying. So to undo that, I'm going to divide both sides by 2. And so then now I need to figure out, okay, what do I do next? So I look at this and I see that this is a positive number here. So because it is positive 5, I need 2 equations to solve. So the 2 equations I need are the positive version and the negative version of that. So I have x plus 3 is less than 5, and this is a less than statement, so I'm going to write and, so that makes it a conjunction, and then the negative version less than 5. So the positive and the negative version. So subtract 3, so x is less than 2. Over here, I'm going to multiply both sides by -1 or divide by -1. Whenever I multiply or divide by a negative, I need to switch the inequality. And then I'm going to subtract 3. So I have these 2 pieces right here. So I'm running out of room, so I'm going to write up here at the top. So then this would give me that x is less than 2, and I need to make sure I'm remembering to put that and statement, and x is greater than -8. So if this had been a greater than originally, right, so in here if this was a greater than symbol, I would have an or, right? So greater than meaning we're going away from the center, less than we're coming into the center. So then I know for my graph, I have -8 and 2, and open circle on both because they are not underlined. So for x is less than 2, and at the same time, x needs to be greater than -8. So we were talking about this section here. So that would be my number line. And then if it asked for interval notation, then I would be parentheses on the -8 until I got to 2. Okay, so there's some inequality practice. Okay, let's take a look at some graphing calculator.
Trinity Carroll, please report to student services.
Okay, so for the graphing calculator, so I'm going to go ahead and, I don't know if you guys can see that. Yeah, you can see that. Okay, so these are my 2 equations here. So the left side of the equation is going to go into the left side. Let me see if I can get this a little brighter. That's kind of tricky to see. Okay, let's skip the graphing oh, wait, maybe. There we go, there's a graphing calculator screen. Okay, so I have to have this at a weird angle, so maybe it'll work out, maybe it won't. Okay, so I'm going to go up to y1, and then I want to type in the left side of the equation into y1. So I'm going to press the 4, and then I need that to be a power, so I'm going to use my caret key, which is above the division. And then I have to make sure I'm grouping that, so x plus 3. So if you're practicing this at home, you're going to be using Desmos, but it's still the same kind of idea. And then minus 2. So I did 4 to the power of x plus 3 minus 2, so the left side, and then now I'm going to put the right side in, so this one here. So 5 minus, make sure you're using subtraction over the negative, right? So make sure you're paying attention to that. And then once I get that, I'm going to go ahead and graph it. So this is really just to kind of jog your memory on those steps, because I know you don't all have calculators at home. And then I have 2 intersection points, and so I'm going to go to calc, and then number 5, which is intersect, And then enter, right? Because we've got first curve, we're good. Second curve, we're good, because we're only going to ever graph 2. So then if I want the left equation over here, I'm just going to kind of count 1, 2, 3, like somewhere around -4. So I'm just going to ask it to look around -4, making sure I use the negative. And so then there's my first solution there. So that would be the -3.556 if I truncate, or -3.557 if I round. And so then if I want to find the other intersection, I just go through and do the same thing again. So I'm hitting calc, number 5, enter, and then for my guess, it looks like around -2 maybe. And so there would be my second value. Okay? All right. Moving on, people. Okay, so let's take a look at this one. So these directions would say something along the lines of, rewrite or simplify this equation. So in order to do that, the first thing we want to do is factor this. So I'm trying to come up with my values, right? So x squared is x times x. 9 could be 1 and 9, or 3 and 3. So we know x and x, and then it needs to multiply to the +9, so they can either be both positive or both negative. Because that is a negative, they're both going to be negative. And I want it to add up to -6. I don't know why I circled that one. And so that would be -3 and -3. If I have the same factor twice, I can write it as a squared. And then the square root of something squared is absolute value. But we are still not completely simplified. So we are given this domain restriction for values of x less than 3. So that would be numbers like 0, 1, 2, all of those numbers are less than 3. So if I were to evaluate this at 1, for example, this would be a negative number, right? So any number I evaluate this with that is smaller than 3 will be negative. So I have one more step I can do to simplify. So then I want, if that's negative, I undo that by putting the negative here. And so now when I substitute in example number 1, I would get this would be -2, but then that negative would turn it positive, which is what the same thing the absolute value does. Okay? And that would be my answer. And you can distribute or not distribute, it doesn't matter. And let's do one more just to make sure. So again, I would factor this, so I'm just going to factor it for you this time. And again, the directions would say to simplify. And so if I have the same factor twice, then I could write it as squared. And then the square root of something squared is absolute value. And so again, I want to do a test point, right? So I have the values of x that are greater than 3, so like 4, 5, 6, that kind of thing. So if I evaluate this at 4, I would get 4 plus 1 is 5, and so I don't need those absolute values because it already is positive. So then this would just be x plus 1. And I need to make sure I'm remembering to put this little disclaimer here, right? Because that is only true if my values of x are greater than 3. So that always needs to be part of my answer. Okay? All right, so there's a couple of those. So for this one here, so the directions would say something along the lines of rewrite as a piecewise equation or piecewise function without absolute value. So a rewrite into a piecewise. So when I rewrite this as a piecewise, I'm going to have 2 equations, and then my top one is going to be my original, right? So this needs to be my original. And then this one's going to be my opposite. And when I'm talking about original and opposite, I'm talking about the absolute value component, right? Like what's inside of here. So this is original or opposite. So my original, meaning it is just x minus 3 the way we see it, so I'm going to group it. And then the opposite would be, the opposite of that would be the negative version. And this would only be true if this was positive inside of here. So that's only true if x minus 3 is greater than or equal to 0. This would only be true if this section was negative. So if this section was negative, and so how I write that negative is if x minus 3 is less than 0. And then as far as the equality goes, standard form is to have the original be the equal component and then the opposite be not equal. But if you had this as equal and this not, that would be okay as well. And then I'm going to go ahead and simplify this just a little bit. So I could combine the negative 3 and the 2 here if I wanted. And then on this one right here, I would add 3 to both sides. And so then this would be, ignore that phone ringing, people. And this would be if x is greater than or equal to 3. Okay. And then I can distribute and combine like terms on this one as well. But I'm not going to, but you could, right? So you can certainly do that. They are persistent. Okay, so then here I would add the 3 over as well. So then that would be x is less than 3. Okay? All right, so, and that would be my piecewise. So my original and my opposite. Okay, let's do another one here. So for this one right here, I want to go ahead and do the same thing. So rewrite as a piecewise, but we're also going to graph this. So rewrite as a piecewise and graph. So if you remember, one of the tips that we talked about was always to do a GCF factoring to make the problem simplify easier for you as you're working it out. So I'm going to go ahead and factor out that 4. And so that will help me simplify as I go through later on. So we're going to do my piecewise. So remember, this is my original on top and opposite on the bottom. So again, when we're talking original and opposite, we're only talking about the absolute value. So right here, so this is 4 and then x minus 2. And original here is going to be exactly that. So this will be original. And this will only be true if that was positive. And I cannot equal on this because if I wrote it as equal to 0, then it would be 0 in the denominator, and we can't have that 0 in the denominator. So no equals here. And then for my opposite, so I have 4 and then x minus 2, so this is still the same. And then now this part is going to be opposite. So opposite of that. And so that is again only true if x minus 2 is less than 0. So then from there, I do want to simplify these, right? Because if it simplifies, I need to simplify this. So right here, both of these, the x minus 2's will cancel and reduce down to 1. So this original would reduce just to positive 4, and then that would only be true, and if I add the 2 over, if x was greater than 2. And then over here, 4 divided by negative 1 would be negative 4, and that would only be true, and add the 2 over, if x is less than 2. Okay, and then let's go ahead and graph that. So this is saying, these are my y values, right? So both of these are my y values. So when y is 4, that's only true if x is greater than 2. So here is 2. So y is 4 if x is greater than 2. So here's y equals 4, but only true if x is greater than 2. So that would be to the right, because greater than 2 would be 2, 3, 4, 5. Oops, I was covering that. Okay, so let me say that again. So if y is 4, that's only true if x is greater than 2. Okay, so I went to y equals 4, and x is 2. Open dot, head to the right. And then right here, this is saying my y values are -4, so my y values are -4, so that's down here. And that's only true if x is less than 2, so that would be that way. And that would be my piecewise graph for that one. Okay. All right. Let's see. Okay, so I just have a couple more here, or 3 more to do. Okay, so this one is just a graphing. So we're going to go ahead and take a look at graphing this. So we're going to do the quadratic graph here. So I'm going to subtract that 3 over. And then we're going to have my linear absolute value. I'm going to add that 1 over. So for my start, so I'm going to do alphabetical order. So I look at the x plus 4. So then I'm going to use -4, because that would make that 0, and then +3. And then my stretch for this one is -1. And then before I graph, I pay attention to that inequality, because this is where most of your mistakes are going to happen if you don't pay attention to that. So I should be using an open dot and a dashed line. Okay. So I'm going to -4, 3, open dot, and then I have a stretch of -1, so down 1 over 1, and reflect. Alright, and then let's take a look at the absolute value one. So my start is alphabetical order, so my x value, and then my y value, and then I have a slope or a stretch of 2 or 2 over 1. So, oops, I forgot one thing here real quick. So for this particular graph on this one over here, I want to be below, right? So this is less than, so I want to make sure I shade below. So I'm going to just write here that I want to be below that. Okay. So then on this one here, so again I want to look at the inequality. So this is greater than or equal, so because of that equality, I want to make sure I use a closed dot and a solid line. And then greater than, so I would be shading above. Okay, so let's graph that one. So I have -2, -1, so -2, -1, and then a closed dot, and then a slope of 2. So I'm going to go up 2 over 1 and reflect to the other side. And I want to be above. Okay, so I need to be below the quadratic, but I need to be above this line. So if I'm going to be above this line, it would be all of this section. But of that section, the only part that is staying below the quadratic is this tiny little piece right here. So that would be my solution there. So normally I would ask you for 2 points in the solution set, but because I just made this problem up and I'm not on graph paper, I have no idea what points would be in here easily. So I'm going to skip that part, but in general you would look for 2 points that are in your common region, and then you could substitute them in and check to see, you know, would they stay true for that inequality. Okay, let's move on. Okay, so 2 more here. So this one, the directions would say to something like show the solutions to the system both graphically and algebraically. And then it would have, I just realized, you know, something along the lines of, you know, less than g of x less than or equal to h of x. Okay. All right, so I'm just going to do the algebraic piece. If you need to review the graphing, just maybe look in your notes for that part because we just did a couple graphs already. So hopefully the graphing is okay. All right, so I'm just going to evaluate this. So this would be 1 is less than, and then replace g of x, and then replace h of x. So I have to, this is a combined inequality. I need to look at it though as two separate. So I'm going to start with that one over here. So this would be 1 is less than the absolute value of x minus 4. And this would be an and statement because that's the only inequality that would combine. And then from there, I want to take a look at the other part. So this part right here. And that's going to be a separate equation. So that's going to be a separate one. And so now I have the two inequalities and I have to solve for both. So this will give me a pair of inequalities and this will give me a pair. So I'm going to end up with 4 inequalities that I need to pull together. So I'm going to switch this around to my variables on the other side. And then solve this. So this is a positive value, so I'm going to create 2 equations, the positive and the negative version. And then I knew it was an or because it's greater, and then solve this. So I'm going to add 4. And then I'm going to divide by that negative 1, remembering to switch the inequality, and then add 4. Okay, I had to check my math. And then do the same thing over here. So 2 equations, positive and negative. Add the 4 over. Oh, I forgot the and statement. So there should be an and here because it's a less than. And then divide by the negative 1. Don't forget to switch the inequality. And then add 4. And so then that would give me x is greater than or equal to negative 2. Okay, so once I get all 4 of these, that is not my final answer. I can't like box it and be like, ta-da! I need to like actually put all of those ideas together. So I like to do it on a number line because it kind of helps me process it. So I have these 4 numbers and I want to put them on in order. So negative 2 is my smallest and it's an equal, so that would be a closed dot. And then 3 with an open dot, 5 with an open dot, and then 10 with a closed dot. So right here, so I'm just going to start this way here. So I have x has to be greater than 5. And it has to be less than or equal to 10. So that would be this section right here. So, or x has to be less than 3, and x has to be greater than or equal to negative 2. So that would be this section here. And so we would want our answers always in interval notation. So I'm just going to go from left to right. So we are closed on the negative 2, closed dot. So bracket, and then parentheses, open dot for 3. And the second set is starting at 5, open dot, so parentheses, ending at 10, closed dot, bracket. And so then that would be that solution. Okay? All right, one more here, people, one more. All right, so cubic. So I should have 3 answers. So the directions would say like solve for x, both real and imaginary. So this is a cubic, and so for that, I know I should have 3 answers when I'm ending. If this was a 4, I should have 4 answers. So we should always be checking that. So this is cubic factoring. I check for GCF. Can I factor anything out of both of those? And I can't. So then I want to follow my pattern. So I want to find my roots. So to find a, I'm trying to figure out what number multiplied by itself will give me x cubed, or what variable in this case, so that would be x, right? And so again, that's because x times itself 3 times would give me x cubed. So x is the cube root. And then for b, what multiplied by itself 3 times would give me negative 125, and that would be negative 5. And again, it's because if I multiply negative 5 by itself 3 times, I would get negative 125. Okay? So then now I can go ahead and factor this. Okay, so I'm just going to kind of rewrite that. So A is x, and B is negative 5. So when I go to factor, it's going to be a binomial and then a trinomial. A binomial, then a trinomial. So for that binomial, it's the roots. So my roots were x and negative 5. And then over here, I'm going to square, multiply, and then square. So square the first root, so x times itself. Then I'm going to multiply these two together. So x times negative 5 is negative 5x. But we always want to do opposite on that middle term to get all the terms to cancel that I don't need. So multiply but opposite, and then square the last one. So negative 5 times itself is 25. And then now I have to solve it. So I'm going to go ahead and split this, and I'm going to set that equal to 0, and this one equal to 0. And then just solve. So add 5. So x equals 5 is one of my solutions. And then over here, I know I'm going to need quadratic formula, right? So almost every time it's quadratic formula. There's like one exception out there where it's not, but you are not going to see that with me, okay? So I'm just writing down my coefficients. So A is 1, B is 5, and C is 25. And then now I'm going to do quadratic formula. So x equals negative b plus or minus radical b squared minus 4a and then c, all divided by 2a. Okay, so when we're doing these, we want to simplify inside the radical. So 4 times 1 times 25 is 100. And then 25 minus 100 is negative 75. And so now I need to break down the 75. So for factors of 75, I know I can do 3 and 25, 5 and 15. And I can keep going, but I already have a perfect square, so I'm just going to use that. So I have negative 5 plus or minus, and then that negative is going to come out and become an I. And then now for my 75, I know the square root of 25 is 5, and then I don't know the square root of 3. So the negative became the I. 25's root is 5, so I want to put that in front because I5 doesn't make sense. And then the square root of 3. And then because I have an imaginary number, I need to split it, right? I need to have the real part separate from the imaginary part. So then I would have negative 5 over 2, and then 5i root 3 over 2. So I have all of my answers here, so I'm going to put them in a solution set. And there we go. Okay, here's a little tip for you guys. So if it is a cubic and you don't get a root 3 here, you made a mistake. This will always be a root 3. Okay, and that's it.